wanted to share a little code base with you that was something I had to deal with in my previous company that I worked at, where we had a need to stream video data in real time to multiple devices, making sure that all the devices were practically in sync. And we had to be able to support that on both Android and iOS and all other major platforms and browsers. So the thing that in the end ended up working really well was to stream video data over WebSockets. And it's actually kind of an interesting little code base to explore. So I figured we might as well try it. So let's start with our main file, and let's just delete all that and start a new main package and a new main function. So the pattern I'm going to use here is to use something like a booter structure. So I will just use the package sockstream as I have come to call it. That's what it will be called on GitHub. And then I will run my booter. So now this will obviously have errors because we need to implement that. So first we will create our package called sockstream, and in there we will create a new file called booter.go. Alright, so you can delete anything that's in there and then make that part of the sockstream package. And now we need a new type, which is the booter struct. That's going to sort of serve as an object that we can attach state and methods to. And what we will do here is we will create a hub, which will be a pointer to a hub type, a router, which will be a pointer to a router type, and a capture, which will be a pointer to a capture type. Alright, so this will also make a lot more sense in the very near future. So first we will create a new constructor for the booter, make that return a pointer to our booter type, and then we will create a new channel. I'm going to explain this. Okay, so we will use OpenCV in Go by way of a package called GoCV, and we need a matrix to store frame data in from our webcam. That is going to make more sense also once we implement the capture object. So also we will create a new hub and pass in that capture channel. And then we can return our initialized object. So add the router and add the capture by way of new capture hub. So we will still need to implement capture hub and router. We haven't done that yet. We're just setting things up right now. But we will try to go through it in a sort of a structured way. This should not take that long to make a basic version of. So now we want to run the hub as a Go routine. Booter capture run, and now we can run the router not as a Go routine. So we have something that blocks the main thread, otherwise the program will just exit. Now this will give us a lot of errors. It will import this GoCV package. Please go to the GitHub for that and follow the instructions on how to install it, because it's not it takes a few extra steps than a normal Go package, but it's worth it because it adds a lot of functionality for video. And I've been really interested in video lately, partly because one of my jobs, like I said, was dealing with that. So let's implement our hub first, and then it will start to become a little bit more clear what that is. So create a new file, hub.go, in your sockstream package. So we can leave that. Then let's first define the type. Oops. Hub is a struct. So the hub will have clients, and that will be a map of pointers to a client type and a value that is Boolean. It will have a broadcast, which is a channel of bytes. And it will have a register channel, which will be of type client, pointed to client, and an unregister, which will be a client. Right? So we haven't actually defined client yet. I wonder if I should do that now, so it'll be a little bit more clear what that is all about. Yeah, let's implement client from the top down, and then that will become a little bit more clear. So, create a new file, client.go. The package is correct. Now let's define a few constants. We will need something like write wait, time of seconds. We need pong wait. Alright, ping period. Divide by 10. And max message size equals 512. And I saw that that was not correct. I don't know why those are red. Most likely if I actually exit that and open it again, there's a bug in my editor, most likely. It happens sometimes, yeah. Okay, so now let's define some variables. A new line will look like a byte, a rune of -n, /n, sorry, and a space equals a byte of space. Yeah. Now we need an upgrader. This is to upgrade a normal connection, HTTP connection, to a WebSocket connection. And it needs a read buffer size. Some of this is just as much sort of magic to me as to most. I am reading up more on that, but these buffers and stuff, these are just things that sort of come with the package, as in this is what it sort of is described on the GitHubs for the various packages that are being used. In this case, I think it's Gorilla WebSocket we're using. Okay, so let's create a new client type, because that's what we needed in our hub. In this case, I'm passing in the hub. Okay, I need a connection to WebSocket connection, and I need a send channel. Sorry, that's a channel of byte. Right. Now we need a method on that client struct that is called read pump, and this will send data through the WebSocket channel that we can read. So first we create a deferred function. Making sure that we can unregister from the hub of connections. Make sure that we actually execute that function by putting the brackets there. And then set read limit max message size This you really only have to do once whenever you need a WebSocket connection in your Go programs. This is basically what you can use to set up a fully functional client. WebSockets in Go are extremely fast, by the way. I've seen them perform extremely fast. Set read deadline time now. Oops. Dot add long wait and return nil. Put the comma there, otherwise Go gets upset. This is the one thing I don't like about Go. It's that extra comma at the end of everything. I get the thinking behind it. I just don't like it. Alright, so lots of error handling we need to do. Always fun. This is all basically boilerplate, like abnormal closure. Yep. Fine, then we can print the error. Otherwise, bytes.trim space bytes replace message new line space -1. Alright, and then now we can broadcast the message, and the message in this case is actually oh, this is read pump, so that will be coming from the client that we will create later. So this will broadcast it to any connected client. Then now we are going to write the method that is actually going to be able to send video frames over the WebSocket, which we can then decode on the client side, and we will do that as well. So let's add another method on our client struct. In this case it's called write pump. This needs a ticker, find out new ticker ping period. Then defer func and close the connection behind us. Make sure that we actually execute the function. Infinite for loop with a select. So now we're going to select over channels. And this is a way of reading out multiple channels. So you use the select syntax, and then you can say like, okay, well, if I'm reading from this channel, then I can do this, and so on. I wasn't lined up with my keyboard correctly, I think. Right, message, WebSocket.close, message, Okay, here we obtain a writer that we can use to write to the clients. Let's handle the error real quick. Just return, ignore it, and write our message. Our message is a byte encoded JPEG, basically. Simple for loop. Write a new line. Write whatever comes from that channel. And handle error. Oops. Now you see the power of that select. Now I can also read from the ticket channel and do something completely different. So it's basically like iterating over channels. Well, I guess it's not iterating because, yeah, it's literally selecting over channels. So the syntax is actually quite good, even though it's a little weird because coming from other languages you might be used to select being something different, but yeah. Too bad that there's so much boilerplate involved in this WebSocket stuff, because all this really doesn't matter for our functionality that much. We just have to do it to handle all of our cases. Something didn't go right. Why don't you like to line up? Ooh, something is wrong. Okay, that's good. Why doesn't it like message? Because I spelled it wrong over there. Alright, that's good. So now we just have to do one more thing, and that's write a tiny little server for our WebSocket. So serve WS. Let's pass in the hub. Let's pass in an HTTP response writer and the HTTP request. Because we're going to need those. Now, upgrader, check origin. This is a bit of a hack to get around some CORS validations. This will basically allow for any request to fall through, but like you can obviously implement your own security if you need it here. And now let's upgrade our writer and reader. So basically our request to a WebSocket. Yeah, okay. Handle the error. Print the error and just return. Then create a new client. Pass in the hub. Ooh. Pass in the hub, the connection, and make a channel of bytes, buffer it to 56, but it's arbitrary for now. Okay. I always misspell that. Response right there. Happy? Yeah. It says because client isn't being used, client, hub, register. So now we send to that registering channel the client, and it will be registered as a active client. And then we start write pump on that client, and we start read pump on that client. Alrighty, so now let's finish hub. Now that we have the client, we all did that just because we wanted to make hub work. So let's finish that. You can see now here that register channel that we sent the client to. You'll see how that works right now. So constructor. If we remember from main, we had a capture channel that's for our camera that we were passing in here, and that's a GoCV matrix type. So return reference to hub. Broadcast is, we have to make those channels, like allocate memory for them. That's a byte channel. Register is a client channel, pointed to client. Unregister is channel to client again. And clients is a map of client with values of booleans. Alright, now we have to define that method on our object, run, that we call to actually run this hub, which is just an infinite for loop, and another select over channels. This select syntax you will see me use a lot because I work with this hub structure a lot, where things are basically like, it's like a ghetto version of a queue, of like a RabbitMQ queue or a Kafka, but like really simplified. Just some debugging messages so we can see what's going on. This is when a client actually disconnects or something. We want to unregister them from our list of clients. So what we do is make little if here, and check if in our clients the current client is there. And if that is true, then we can say delete from the client list that client, and then close its send channel, so that we have some. I'm actually not going to put these log lines in there because it's just extra typing. And then on the broadcast channel, when we read from that, we want to just loop over all of the clients. So clients, and then do a quick select there as well. And then if the client send receives from message, then do nothing, and otherwise default. I just want to make a non-blocking channel. We use a default clause in our select, in our case select, to make sure that we're not blocking anything. Because if you don't read from the channel, that channel will be blocked unless you do some tricks. And one of the tricks will be to do this. That should be pluralized, so clients. And now it's, oh, I overwrote the brackets. Okay, that's hub. So we had a few more things we needed to implement. Let's do capture. Capture is actually quite an interesting one because we haven't actually worked with the camera at all yet. So let's create a new file called capture.go. And it's from the package sockstream as well. So create the capture type. Yeah. So now we're going to actually read from the camera. So what we need is a device, and that will be a pointer to a GoCV video capture type. And also we want to store a frame. So we're going to read frame by frame from the camera, and we want to pass in our hub and send those frames over through our program. So let's create a new capture constructor, pass in the hub, and return a pointer to our capture type, which we're going to initialize. Let's first initialize the device. So GoCV open video capture. And if you just pass in 0 here, it will grab the first available device, which is usually your webcam. That's the naive way of just getting to your camera quick, to a camera quick. Like, take whatever is the first device. If you can, log the error, obviously. And when we just initialize our struct over here, create a new matrix to store frame data in. Obviously, don't forget the comma. Attach the hub. That's done. Okay, now all we need to do to make this work. What did I do wrong? It says line 9, right? Interesting, I don't see it. I do not see it. Why is it wrong? There's some weird illegal character somewhere. Oh, it says on line 9, column 35. You know what? I don't know what's going on over here, but that should do it. That should be spelled with a capital. Okay, so now to make this finally work, I honestly don't know what happened over there. We make a new run method on this capture object. So first we want to make sure that we close the device by using a deferred method, and also make sure that we close the frame by using a deferred method. So deferred methods, as usual, they are executed at the end of a function, not when you define them here, but at the end once the other code in your function has been run. It's just syntactical sugar for you to make it more easier for you to remember to close certain objects correctly. And you don't have to go and read through your code whether or not you've closed the object correctly and released like file handlers and stuff. You can just do it with a deferred function, and it will be right underneath your opening code. So here we encode the image as a JPEG because you get a more raw frame. The frame data that's coming in is in a more raw form as a matrix of floating point numbers, and we want to convert that into a JPEG byte sequence so that we actually have displayable data that we can decode on the front end, which we're going to do soon. So now we take the hub, and to the broadcast channel we can just send that buffer. The buffer is just a frame data encoded as JPEG. That's what we're sending now to the broadcast channel on our hub, meaning that all of our clients will that are connected will actually receive that. So I think we're pretty close. We need a couple more things. We now have the booter to capture the client, the hub. We still don't have the router. We do need a router, so let's create that now. I'll leave that other one there and create a new file, router.go. Right on. So, create a router type. This is starting to become familiar now, I hope. We need the hub in our router type, so new router, hub, and return the router. Most of the times I work with constructors like these. It's just something that I found in the end makes it more easy to architect software in Go. Just use constructors. I didn't want to do it in the beginning because I didn't feel like I needed it, and I hate using stuff when I don't need it. I like to keep things as bare bones and simple as possible. But yeah, so we need a HTTP handle func. For just our root path is fine, and we need a handle func that is that satisfies the interface of handle func. So that means we need that response writer and the request in this exact fashion, and then we can use that little server that we wrote, which needed the hub, the writer, and the request, and then we can wrap in a logger just the listen and serve. We will run ours on 5002. So that's our router, very simple, doesn't take much. Don't think we actually use this right now, so let's just see if our code runs, because that'd be kind of cool. So just type in go run main.go. Sockstream is undefined. That's because it never managed to import our package, but if you just do a save and you have all your Go binaries installed, that should be fine. Otherwise, replicate this import line, obviously with your username for GitHub and stuff. Alright, so we have a couple of things wrong in Booter. Some of that will be similar, so we can just load in packages now. And there was also a syntactical error in there, but now I don't see it. Interesting. Oh yeah, that is not man but make. These cherry browns, they're still not really working for me perfectly. So router is actually never created here, why not? Oh, don't understand why I did that. That should actually call the constructor, and the constructor needs the hub. I think that's correct. I think it's bluffing and it's not wrong. That is correct. Okay, so now, and I actually saw my camera come on, so that's all good. The only thing now is we need a client, and for that we can actually just write the simplest index HTML page. So basically, let's just run over it real quick. This is all just a very basic HTML header. I set margin 0 and padding 0 on the body. I set width 100%, height 100% on the ID tag of video. And then I create an image tag with the ID of video, and the source is just empty. So what I do here is I'm actually connecting to our newly created WebSocket Server. Here we said we ran it on 5002, and I create a new WebSocket that connects to that address. So then the socket binary type I set to array buffer, because that's what we're actually getting. And here I have this little thing that I found on Stack Overflow that can convert our array buffer, which is JPEG encoded data, into a blob. And then what we can do is actually convert that into an image URL and inject that into the video source. And that is the bread and butter of how we are actually injecting the frames continuously into this image tag. And because the fact that OpenCV already takes care of reading out the camera at 30 frames a second, it should actually be the case that that's going to limit the throughput on the WebSocket correctly already, so we don't have to resynchronize any frame data that is coming in. At least not yet. This is the simple version. So at the moment, you can see nothing is happening because there is no WebSocket connection, because we're not running our server yet. But if we run the server and I wait for my webcam to go on and I reload this page, now I'm there. Even cooler is you can actually go to network, and here in the WebSocket you can you should be able to see the frames. Let's try it again. Well, it's weird. This is happening a few times now with Chrome, where I cannot actually go into the WebSocket anymore, but okay. Sometimes you can see the frames here. It's weird that it isn't working right now. Yeah, here now you can. So let's try it again. Oops. What happens now? No. But anyways, like you can see, the frame data is coming in. So that was my little sort of proof of concept that I did in my previous job to get a real-time video stream. And I'm actually working on some projects with video right now that uses some of this as sort of a basis. It's not using this exact type of video streaming, but it's good to know this. Like if you are interested in OpenCV and video streaming, and you want to follow along with some stuff that I'm going to be doing soon, then this is a good basis to have. So that's it.